All right, what's up? How's it going? How's it going? A bit late, but fashionably late? Okay, all right. Some people just don't like to say hi, I guess. I don't know. Is that rude? Is that ATP O level will start soon, Omar? Ready? Past paper questions, yes. So we'll see a bit of organic questions. We'll see a bit of mostly polymer questions. So we're trying to do as many polymer questions as we can without trying to find, without trying to, how you say? What did I want to say? I forgot. Let's just scratch that. Let's start. Okay. Can we do this question? Let's start with C1. C1. We won't be doing all of the questions, focusing on the mechanical part of it, but let's see if we can do C1. We'll avoid moles questions for sure. There's an interesting question which is C part 2. Let's see if you guys can handle that. How's the audio quality, YouTube? What question do I want to do after this? There are quite a few questions. Can we go fast if that's not too much to ask? Maybe we can finish the entire worksheet in one day. Ow. Oh, there we go. Don't you dare. Don't you dare. Okay. All right, what's the answer? Okay, I already answered that. Identify product A. Product A gives a squeaky pop when ignited with a burning splint. In an experiment, C10H22, I believe that's an alkane, is cracked to form three products, A, B, and C. A gives a squeaky pop when ignited with a burning splint. What is that squeaky pop? What is that, guy? Do we not know? Hydrogen, okay. Yes. They're just talking about hydrogen. That's not the pop, and the pop is a lot like, yeah. Right? And, okay. Product B has a relative molecular mass of 98 and decolorizes aqueous bromine. Suggest the molecular formula for B. What do you guys think? Is this doable? I think some people are able to do it. There are two ways about it. Right. What do you guys think? Is this doable? Show of hands if this is doable. Musrat, what do you think? How many people do we have watching? 3 people. Hello, 3 people on YouTube. I think only Rida said. Musrat is confused. Okay. You have to do a bit of calculation. Okay. The easy way, if you don't know what to do, is the MR is 98, right? That's what it's telling you. The MR is 98. The other thing it's telling you is that it's going to decolorize aqueous bromine. So that tells you it has to be an alkene, right? Now, the simple way about it is there's some formula, some alkene. The general formula for an alkene is CnH2n, and the MR for this guy is 98. Can I say with utter confidence most of the MR is going to be because of the carbon, because hydrogen is just 1 in its weight and carbon is 12, right? So most of the weight will be by carbon. So I'm just going to guess here. My best guess is going to be 98 divided by 12. So I'm going to take 98, divide that by 12. I get 8.16. So I'm going to guess, I'm getting 98 divided by 12 as 8.16. I'm going to guess there are 8 carbons, right? If there are 8 carbons, the hydrogen needs to be how many? Well, it's C8, it has to be 16. What is the MR for this? C8H16? So 8 times 12 is 96 plus 16. 112, that's too high. That's too high, but we're very close to the correct answer. 112 is not too far from 98. So I could have carbon to be like, the carbon needs to be lesser than 8, right? Let's try 7. If it was 7, what can you do? What can you do? How many hydrogens will you have? I think you'll have 14 hydrogens, right? And 7 times 12, trying to figure out the MR for C7H12, 84 plus 14. That's exactly 98. The MR for this comes out to be 98. So this has to be C7H14. Heptene. Why did I divide it by 12? The idea is most of the weight is contributed by carbon, right? So if I divide the MR for, like, this is the calculation for MR. If I just focus on carbon, N would be the number of carbons multiplied by the MR of carbon equals to 98, approximately 98, right? That's what we're saying. So if I want to figure out N over here, right? That's the challenge. I'll just say N divided by 98 over the MR of carbon, which is 12, or MR of C, which is written over there, MR of C. So I'm trying to approximate what value I should approximate my C as. The other thing I can do is start with, you know, C2H4, that's my smallest alkene possible, and move my way upwards. But, you know, when I do this trick, I realize my weight is going to be very close to, you know, like I figured out how many carbons do I need. So I got 8, which was wrong. I got slightly higher when I figured it out. Then I got, then I took it 1 down and we said C7H14 and we got 98 exactly. And that has to be the molecular formula. Does that make sense to people? Got it? Okay. So most people got it. Now here's another way of doing it. This is the proper way of doing it. I showed if you don't know what to do, that's how you do it. This is the proper way of doing it, which is probably more tedious. The idea is you still know it's CnH2n, but you don't know the value of N. But you know there are N carbons in the molecule and 2N hydrogens in that molecule, and the MR is equal to 98. So you replace these values with their MRs, and what do you have? You get 12N plus, this is just going to be 1, so it's 2N equals to 98, 14N equals to 98, N equals to 98 over 14, that should give you exactly 7. So 98 divided by 7 is what? 14? 98 divided by 7 is 14? Am I doing something wrong? Oh, why am I dividing it by 7? 98 divided by 7, oh, I keep doing 7. 98 divided by 14 is, oh my god, my calculator is, yeah. I'm getting N as 7. So if N is 7, 2N has to be 14, and that's my molecular formula. Does this make sense? Do you guys understand these? Do you guys like this way, the second way more, or the first way more? You can use whatever you want. The second way is more easier? Okay. Use the second way. I'll just hide this because I want to work. Try to answer the next question. What is my explanation for this? It's a 1-mark explanation. So the idea is you're trying to say why, suggest the molecular formula. And the explanation is that why do you think it's an alkene rather than an alkene? That's what they're getting at. So why do you think it's an alkene? Be decolorized aqueous bromine. So it has to be an alkane alkene I meant, with the general formula CnH2n. Does this make sense? Only an alkene. Okay. I'm surprised most people like the second. Most of likes the first one. I actually think both are smart. The only issue is that I get so many compliments, sir. You're a lifesaver. You saved our lives because you made A-level chemistry. I didn't make A-level chemistry, I guess. I'm only helping with O-level chemistry anyway. But thank you, Nabia. I'll carry forward the message. But I lost my train of thought. That's unprofessional. Yeah, you have to already be able to do that once to be able to do the second way. If you did it the first way, I think that's also has merit. Okay, product C can be polymerized to give a polymer shown. Draw the structure of product C. What kind of polymerization is this for which we see a repeat unit as such? Can we look at it and recognize what polymerization this is? And if someone is confused or guessing or anything like that, I'm gonna... Okay, some people are saying additional. Why is it addition? Why is it additional polymerization? Why is it additional polymerization? How do you know? What's telling you? There's nothing here to tell you. It's additional polymerization. Well, you're explaining, Rida, you're saying carbon double bond is broken. You're explaining additional polymerization, but you're not telling me why looking at this, it's addition polymerization. Why is this addition polymerization? When I look at a polymer, how do I know which polymerization it is? So we've done 3 types of polymerization. We've done addition. We've done addition. We've done condensation. Now condensation in detail, we've done 2 types. One is how a polyester is made. The other is how a polyamide is made. And for each of them, you could have one monomer. What happened to this? What happened to this? Strange. Something's wrong. Give me a second. Give me a second. How do I... It shouldn't show this. Which one was it? I think we were here. Yeah, should work now. So polyester, is it working? Yeah. Okay, thank you. See, I told you there's a lot of problems going on. Polyester. This is a ester linkage. If you see this in a polymer, you know it's a polyester. If you see, close to that, something like this, it's a polyamide. I forgot to complete the word polyamide, right? And the H could be on the other side as well. It could be here. It doesn't really matter, right? Now for addition polymerization, you don't see anything, and you can see there's nothing really indicating that it's an addition polymerization, because the reason is that you start with a carbon-carbon double bond, right? Something like this, and it opens up. I don't have room here, so I'll take that here. It opens up like that, much like how two dancers open up their hands, right? This bond from here opens up on either side, like so. The original bond stays in its place. So this is what you end up seeing. So if you don't see an ester linkage, if you don't see an amide linkage, you know it's an addition polymer. And that's the idea. With that said, and that's how you recognize it. Okay. So what could be the repeat unit for this? That's easier. So it opened up here, right? This is the hand that opened up. These are the two dancers, and that's their other hand. So it's gonna join in like that. For I think this is a color which doesn't show too well on videos. So it's gonna be this. Does this make sense to people? Any questions? Rida? Does this make sense? Yep. What is the name of this monomer? He asked, scaring people to bits. We don't know how to name monomers. We don't know how to name monomers. How do we name this? Ramis, what's the name for this molecule? Exactly, it's propene. How do you say propene? It's an alkene with 3 carbons. No biggie. This is propene. It looks very different from how you would end up drawing propene if I ask you to draw it. But no, and this is propene. Okay. Okay. Let's skip. Let's go down to C. What do you guys think? Structure of an amino acid, alanine or alanine, is shown. Alanine can be polymerized to form polyaniine. Draw the partial structure of polyalanine to show 2 repeats unit. I'm messing up the name. Polypropene? The name of the question, the diagram in the question would have been polypropene. The monomer was just propene. Is this an easy question? I think this is ridiculously easy. What do you guys think? Doable? Propene, polypropene. Shall I do this? Or you guys want a minute? Just a second. Okay. I like the question that's right after this. Done. I'll try drawing it. I think by the time they're done, they can almost look up and is it just me or this color is fabulous? And I'll cheat because I can. Because I can. And here's me cheating. And what do you guys think? Easy? Did you get this? Yep. Anyone having difficulty? Does anyone want to ask a question? Everyone got it? Mr. Messam, did you get it? Sorry, I'm yawning. Pardon me. Ramis gets it. Imad boy gets it. Got it. Got it. I love this question. If this doesn't confuse you, then I'm the best teacher in the world. If this confuses you, you're only human. The first time you see this, got it. What is the question trying to ask? An ester linkage with a doubt? Well, there are only two linkages you've done. If they've already talked about one, you're absolutely correct. I don't like how my handwriting is coming out. Ester linkage. The condensation. No. The question. Yeah, I think. Yeah, the question is not really asking for that, and I think it would be a little more natural if you did the entire question in one go, because you see this is following from the previous question. This is a molecule very similar to the molecule we made, which was a protein, I guess. We're looking at proteins. So they're asking why can this also form an ester linkage? And the why is because there's another alcohol group. So another molecule of this can either, if there was, this is the cool thing about over here, if there was another molecule Huh? Wow. If there was another molecule, right? The acid could form a link with the amide, form a polyamide, or I think it's going to be really funny if I do this. Why do I think it's going to be really funny if I do this? Or I'm just very entertained right now. It could form a bond between these two together, like that, right? So it can also make a polyester. So the reason why it can do both is, what was the answer given? By condensation, but through condensation. But the reason it can do both is because there's an alcohol group and an amine group, right? So explanation. What is explanation really? Name this link and explain with a different. It can form because the explanation ester linkage, the E went away for some reason. And the reason for it is it also has an OH function group, alcohol functional group. Does that make sense? Miral, does it make sense why it's not by condensation? That's the process, but they're asking, why does this? Imad's got it. Because the alcohol is present, it can undergo both, you know? Okay. Let's see if I have more questions. I have so many questions. Okay, let's do part B. This question, we did part B. Did we? Have we done this before? I guess we did this last time. Do we have, did we do this yesterday? I guess we did a few questions. This is, I don't like the question being right after the other one, but this is a very similar question to what we just did. This class is still 7. Why do you ask, Musrat? It's the same logic, right? Yeah. It's the same question, more or less. It has explain, by referring, this is a little clear, by referring to the groups present, why polymers with different linkages can be formed, right? So the acid can react with the alcohol or the, yeah. So you can say ester linkage it's a little too thick. Ester linkage and amide linkage both can be formed. Both can be formed. I am a cretin. Both can be formed as the acid function group function, I'm just going to write FG, can react with both the OH and amine groups. I think I was a little verbose with my answer over here. It's okay, we'll end it at 7. Many people have classes till 7. I think polyethene is going to be a little easy. Can we make it challenging? Can we say, okay, maybe let's do it later. Let's do polyethene. Let's see if we can do polyethene. Anan, welcome. If you guys find this challenging, I have a feeling some might, or maybe if not for ethene, I think people are doing it through memory rather than actually figuring it out. You first try to figure out what ethene is, and this is what ethene is, and this will polymerize and turn into oh, we have to draw ethene. I thought we had to draw polyethene. Okay, let's do that anyway. We had to draw ethene. I guess the question was easier than I thought it was. What is meant by the term non-biodegradable? Can someone answer this? Almost, yeah, it doesn't decompose. I was checking the marking scheme and it says cannot be, it doesn't decompose. It does not decompose. Decompose. It is not decomposed naturally or by microbes or bacteria. ठीक है. Describe one pollution problem caused by disposal of non-biodegradable plastic. They stay forever, and you can name many things. What do you guys think? Amide boy is just on it. Warren says, oh my god. Built up waste. Can we... Yeah, I guess. Can we get a more specific... Yeah, blocks drains, sure. Nah, that's it. That's an issue. Yeah, harmful for the environment. Yeah, marine life endangerment. Yeah. Soil destruction. Yeah. Yeah. I do see that happening. Anything else? I do like blocked drains. I think that's diseases. Why would it cause diseases? Did something happen? That's not how you spell it. Yeah, I like the block strains. I think that's fine. Endangerment to the marine life. Why is this not writing? Blocks, drains, endangerment. Endangerment. To marine life. All right. What's the next question? What's the next question? Question 5 is easy. Let's try question 6. A little different from what we have. I like this question. This is going to be challenging. Actually, like is a weird word. You can differentiate between nylons and, let's say, a protein with the help of this question. It tells you the difference. I did try to emphasize the difference between a protein and nylon, but we didn't really test it, so to speak. Let's see if we can. If you draw the structure of nylon, okay, what do we have? Easy, doable, or difficult? A polyester is shown to us. They're asking for a nylon. Partial structure for nylon. Is this easy or difficult? What do you guys think? Easy? Okay, yes, I was expecting easy. Okay, the difference between a nylon and terylene. Let's think terylene in mind instead of a polyester, because a polyester could be one monomer as well. So 2 monomers would be terylene specifically, right? So the different nylon has to be a 2 monomer polymer, right? It has to have 2 monomers, one with only amines on it and the other one with only acids on it. So this is exactly like that, but over here you just have alcohols on it. So you want to change this to like an NH and put another H here and N over here, and you're more or less done if you do that, right? And do it for all of them. But let's try drawing it. Why didn't I pick a different color? I'm just drawing as many as there are on top, just to copy it. But you don't have to draw these many. And I take this away. It looked better with the line. Now it just looks weird. Easy? Everyone got it? I'm kind of surprised. No one found this difficult? No one found this difficult? Okay, easy. Okay. Yeah. Let's try this one. 1, 2. Let's try all 3 if we can. Let's see if we can. Hang on, I'll be right back. Close. Your answer is close. When alkenes join together without losing anything, breaking the double bond. Yeah. But like you're on the right track. So the key thing is addition, right? Addition would emphasize that only one product is formed. And the easiest way to phrase it is only one product is formed. So you'll see this question a lot, and the best way to answer this is when many monomers react together, or monomers react together to form only one product or one polymer or one kind of polymer. Actually, one product. Yeah, does that make sense? One product, one type of polymer. react together to form one product. That's the most efficient way of saying it. There's no water or anything else formed. Draw the structure of the alkene that can be used to make this addition polymer. This is an interesting question. Oh, I thought we could, yeah, this is, yeah, okay. Hexene, no. Your carbon count is same, but it's not hexene. Essentially, this is your, I'll try answering it. This is your repeat unit, right? And it has to be these things repeating, right? So you essentially put a double bond. You like, this was your double bond, or let me use the highlighter. This was your double bond. This was your double bond. Oh, sorry, I'm saying double bond. This is the outstretched bonds, right? These were made when polymerization took place, and these were opened up from here. So the original molecule was this without these present. So that's not really hexene if you start drawing it out. It's an isomer of a hexene. So if I draw it out, it's exactly like how it looks. CH3, 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 and CH3. Sorry, I just moved it. My bad. What else? Yeah, fills. What do you call those? Landfills. And what not? There was another very nice one last time when we were answering. Harms animals, blocks drains, builds up waste, yeah. Yeah, even trying to process it produces more. Okay, what's the next question? What do we have as the next question? Let's do, it's 6:53, we have some little time. Let's do one question from IGCSE. And it's an Ester question. This is question number 12. We're on question number 6. Wait, I don't have it here. Wait a minute. I don't have it. Let me just take this. Okay, question number, let's go to question number. Where's 12? Let's start with this one over here. Let's see if you guys can do this. So far, I feel this is the more challenging question we've done. Not related to. You won't get alkyne. That's not in the syllabus. So what are you doing? Oh my god. Okay. Amide boy, what's your what do you study? Okay. Mm-hmm. That is interesting. What the... That's weird. Is this one? Mm-hmm. Yeah. Hmm. I think I have to end this soon. What do you guys think? Do you guys know the two esters now? Or is it challenging? And I feel this might be a little challenging. What do you guys think? Should I explain it or should I write down the answer? Challenging? Okay. Once I give you a hint, it's going to be really easy. So if you look at the general formula of the ester, sorry, hang on. General formula of the ester, it's C3H6. That means it can be, like it has only 3 carbons, right? So let me just add a page here. It can only have 3 carbons. 3, that's horrible. It can only have 3 carbons. And an ester is made out of 2 things, an alcohol and an acid joined together. So either you can have an alcohol with 2 carbons and you can have the acid to have 1 carbon, or you could have 1 carboned alcohol and 2 carboned acid, right? And what that would result in is a total of 3 carbons. And that's what your ester has, 3 carbons. Does this make sense and make it your life a lot easier? So you already know this at this point. You have ethanol, and you have methanoic acid. One carbon acid is methanoic acid. And if they form an ester, it would look something like this. Let's get the acid part first. Sorry. Right? I took this, I kept it here, and kept it here because it's losing the OH, and this loses the H, and I took this entire molecule and attached it, flipped it, and attached it here. And what's the name of this? Well, I don't need to figure out what's over here. I can just name it from the products I already drew. So it's going to be called ethyl methanoate. Ethyl methanoate. And the other one is going to be, well, methyl ethanoate, the reverse. And let me draw the molecule of this. Right? A tricky question. Just that one part is tricky. But it was more of a math thing. I felt that was really weird. Not weird of them to ask, but oh well. We remove one from here, take this over there, and add it here. Does this make sense? How many of you guys get it? I think this part was a bit confusing. And if you draw it 1 or 2 times, as you spent like 2-3 minutes on it, you would know you could do it very easily. Because there's only 2 options, yeah? Okay. Let me check one thing. Where'd it go? Yeah. Okay. Does this make sense? Clear? Everyone clear? Where's my chat? Got lost. Okay. Okay, one thing we didn't really touch is what a structural formula is. We've done display formulas. Structural formulas are those condensed formulas you've seen written down. If there was an ester mentioned, you've seen it mentioned. So let me just write it down first and then try to explain what it's trying to do. The structural formula for this, the one on top, is going to be COO. Let me just make it slightly larger. HCOO CH2 CH3. That's the structural formula. Does this make sense? Or do you guys want me to explain this? I think some people might require explanation. We didn't really talk about this too much. Does this make sense? You're welcome, Iman. Mesam doesn't get it? Okay, I'll explain it. Okay, what's really happening is it just tells you how the structure is arranged without showing you the bonds. So if you had, let's say, CH4, right? It would be CH4 like that, because one carbon is written down, like, I mean, that's, yeah. But if you have CH3, right? Or C2H6, why am I saying CH3? It's going to be CH3, CH3. Because when you look at CH3, CH3, you go like, oh, one carbon has 3 hydrogens. So it's like the carbon, you write the carbon first, and whatever is on the attached to it, you just write it down like that. So CH3, CH3. If we do a more complicated one, it starts making a lot more sense. It doesn't make too much sense for smaller molecules. Let's say if you have butane, hydrogens are kind of weirding out. This is gonna look like, this is gonna be, so what I'll do is I'll condense, so to speak, this part of the molecule, this part of the molecule, then this part of the molecule, and then finally this part of the molecule. And this looks like CH3, CH2, CH2, CH3. Okay. So that's one issue with, that's called a molecular formula for a reason. You could have C4H10, which could be this molecule, right? Which could be this molecule, or it could be this molecule. Oh, why am I writing it like that? I could just go CH3. It could also be this molecule, right? Isomers, right? Because this is a different molecule than this, definitely, but this is also C4H10. And when you write it as a structural formula, this would be different, and you'll know these two would be isomers. So if you try to write this, there are actually 2 ways to write this down. So this can be written down as CH3, CH, CH2. You're just trying to group these two together, right? And you write CH3 twice. Or you could write it as CH, then, because on the same carbon you have 3 methyl groups, so to speak, or three CH3s, you write CH3 thrice. Okay, but don't worry about like this sort of nightmare showing up. Like, it's not a nightmare, it's really straightforward. But don't worry about this. But you are kind of asked these things or expected to know this. But does this make sense? Like, this is really straightforward, right? Right? So you see the use of this. So not all the time can you refer to, C4H10 and have to draw it every time you're referring to this rather than this. So at those times, the structural formula is time to shine, right? Now, the only issue is the acid part is slightly confusing. When you have a COO like that, you write it double O. So if you take notice, that's exactly what I did. I wrote the H down first, then the C, then the double O, then CH2, CH3, because after this part, it's just an alkane. So not too much of an issue. Like, I mean, you don't call it an alkane, but it looks like an alkane, right? Does this make sense? Let's try the second one. If we can try to write the second one, the structural formula for the second one. I'll give you guys like 15 seconds. So what you start thinking of it is like this. That's one molecule, that's each carbon. What's attached to the carbon? What's on the carbon and what's after the carbon? As long as it isn't another carbon, you're like, okay. So this is how you group them, and if you start writing them down, it's going to be CH3, COO, CH3. Does this make sense? Okay, I think we'll spend some more time doing structural formula, but I think it's straightforward. If you can imagine the molecule well, you understand what the structural formula is well as well. Does that make sense? Can we end it right now? Because our Bilal has to start soon. Yeah? Okay. We'll do some structural formulas as well. All right, guys. Chalo. Take care. Allah Hafiz. Thank you, YouTube, for tuning in. Bye-bye. Allah Hafiz. Allah Hafiz.